Welcome to this lecture. In this lecture session, we are going to talk about regression in general. We are not going to cover any type of regression like simple linear regression, multiple, polynomial and so on. But we are going to discuss about regression in general. So what is regression and what does regression do? So that is what we are going to talk about in this lecture. So firstly, let's go with some of the definitions in this lecture session. So firstly, what is unsupervised learning? We have already discussed about this type of machine learning, that is the version. And first one is unsupervised. So given item X, if our machine algorithm automatically discovers the structure and the representation. So that means we have only X. We don't have labels to it. We don't have any output that is associated with it. Then that is unsupervised learning. Machine automatically have to discover the structure and pattern for themselves. For example, clustering algorithm is unsupervised learning. Similarly, the supervised learning, given the value of input vector X and the Cx. Cx is something that is an output here at certain point. So Cx, where C is any function. So this both of these data are given. Now we can predict C on future unseen X's. So this X is already seen by data. Now we can just predict this C on future unseen X's. So basically what is going to happen in this supervised learning is we are going to make an algorithm, that is machine learning algorithm. We are going to give the datas like X and Y. We have input and output, both of them data. So input and output will be given. Some data of input and output will be given to make this model. Now after some time, after the model is made, now we are going to basically test this model, because this model is made now, and in order to test this model we are going to give some X's that is unseen by this model before, and this model will give some output and we are going to test accordingly. So this is called supervised. And in the case of unsupervised, we are going to make our model just passing it, that is X's. We have no output whenever we train that model. And this model has to automatically discover some structure, some representation and all by themselves. And that is something like unsupervised learning. So this is the basic type of learning we have here, machine learning algorithm. And the regression algorithm classification that we have been covering in this lecture is supervised learning. So decision tree is also supervised learning because we give X's and output to them. Classification problem is a supervised learning problem. And now we are going to deal with regression problem in this lecture. So that is also supervised learning. We have some X's, some Y's to train, and after the model is built, we will make our model to just predict some C on future unseen X's. So that is our supervised learning, and regression and classification is a variants of supervised learning. Here in the regression we can say decision tree regressor. In the classification we can say decision tree classifier. Similarly, in the regression we can have multiple variants, linear regression. In the classification we will have logistic regression. This is what we are going to just cover in the upcoming lecture, but for now let's talk about linear regression and regressioning. So let's go over here and let's talk about it. So in the case of supervised learning, let's talk about the regression tasks. Given the value of input X, the output Y belongs to set of a real values R here. So that means whenever data is continuous, and here the goal is to predict output accurately for the new input, then that is a regression. So for the continuous data we do regression, and the classification, the prediction or output Cx are a categorical. That means whenever our data is discrete or a categorical, in that case we do classification. It will take X that can be any set of values, either that can be real or categorical, and the goal of classification is to select collect class from the new instance. So basically classification problem is to assign the input to some classes, and regression problem is to basically predict So you can clearly see classification is to classify, regression is to predict some value. So that is all about the supervised learning. And similarly, we have this time series prediction. Data is in the form of moving time series, and the goal here to perform classification and regression on the future time series based on the data known so far. So basically, I have already talked about this time series data set, if you have remembered. So if you deal with the time series data set, that is some data that is dependent on time, and if you do some tasks like classification and regression, that would be time series prediction. So these are the variants of supervised learning. You have X's, you have Y's. In order to make a model, you build a model, and to test that model, we give some X's unknown that has not been seen by this model before, and we get the output. So that is our supervised learning. So we are going to deal with the regression now. So what is regression? It is a predictive technique. So basically, regression is for prediction. Regression is basically to predict. For example, you are predicting like based on the locations, like let's say based on the location where our home is. So you are going to predict the price of that home. So based on the location of your home, you are going to predict what would be the price of that home. Then you are predicting something. So that is a regression task. So basically, regression is a predictive technique where this target variable, target is nothing but a y, which is output. Target means output, and the target variable is estimated to be continuous. So what is a continuous value? Continuous value is something that would be in some standard scale. Like if I say here, if I'm going to predict based on some data, like let's say based on location of a house, I'm going to predict the price of the house. Now target variable here is a price because you are predicting the price. So price is your target variable, which is our output. Now this price is continuous because price is on some scale, because this price has some standard scale, because it would be represented in dollar. So this is a scale. And similarly, the next example could be like maybe you are predicting something like, let's say based on the age of a person, you are basically predicting what would be the weight of that person, how much does he weigh. So for that, you can see our input would be age, which is x, and weight is what you are going to predict, which is our y. So target variable here is going to be weight, and this weight is here continuous because this weight can be measured in some scale like kilogram or pounds and so on. So whenever your target variable has some standard scale, then we are going to use this regression technique. What are the applications of regression? If you want to predict the stock market index based on the economic factor, basically if you want to predict the stock market price. Similarly, if you want to forecast the precipitation based on the characteristics of jet stream. Similarly, if you are projecting a company revenue based on the amount spent for the advertisement. So basically, all of these predictions are continuous. They can be represented on some scale. Like in this precipitation can be on some degree, on some level. And this company revenue that you are going to just predict is some monetary value. That means it can be in dollar, or it can be in pound, or any other that is currency. So that means your predictive value or target variable or a prediction or that thing that you are going to estimate is continuous. So whenever that is your data, or that is your requirement, or that is your basically a requirement of your program, then we do the regression. So regression task is basically a predictive model. It is going to predict what is going to happen whenever you give some input to it. Now this regression task, where we have this D. So D here is a data set. So to do the regression task, we needed some data set. So we need this data set where we will have the X and Y. So X is the input, and for that particular input we will have Y. So let's take example like you are just predicting, like you have a years of experience in one column. So this is a year of experience of your employee, and you are predicting the salary of that employee. Then you can see here the year of experience is your X. That is basically your independent variable. This is what you are going to use to predict the salary. So the thing that you are going to predict is your dependent variable, because this salary will be now dependent of X. So you are predicting Y depending upon X. So this Y is your salary. Now over here you are predicting the salary by the use of this years of experience. So in here you have X and you have Y. So it can be multiple value of X and Y. So this is your data set, and this is required to do this regression task. You will require both X and Y, input and output. So using this particular data set which has both input and output, you are going to make a linear regression model. You are going to make a regression model basically. And in that regression model, now in order to test, you are going to give different X which is not over here, and you are going to get some output for that X. So basically you are going to just use this data, your historic data, to make a model, and that model will be used for future unseen data to predict the value for future unseen data. So that is a regression task. Here you can clearly see it is written Xi corresponds to the set of attributes of the nth observation, and these are the explanatory variables. So explanatory variable is your input, so that will be used in order to do some predictions. Like if you are using years of experience to predict someone's salary, then years of experience is your X, because this is what you are going to use to predict the salary. So it is an explanatory variable, and it can be discrete or continuous. Similarly, Yi here is a target variable. Target variable is your outcome that you are going to predict. Now the complete definition of regression is a task of learning the target function f that maps each attribute of set X into continuous valued output Y. So this function f is your regression, and in case of regression there will be some graph plotted. Like in the case of linear regression, we plot the straight line. So this straight line is our graph. So in the case of linear regression, and in the case of linear regression, this is our straight line, and this function, the function that is plotted over here, that is the equation of a straight line, y equal mx plus c, is this function. So our main goal of regression is to find this, that is mathematical form, which is y equal mx plus c if it is linear regression. So that is all of about regressioning. Now what is error function? The goal of linear regression. So just remember this is very, very important term here. The goal. So what we are going to do in linear regression. So we are now here in the linear regression. So first let's talk about linear regression, and we will go to other variants of linear regression in the upcoming lectures basically. So for now just see here linear regression. So what does this linear regression algorithm does? So let's learn about that. So this linear regression algorithm is going to find a target function. Basically it is going to find a function that can minimizes a error. And what is a error? Error is nothing but this function, and this function should be familiar to you. It is nothing but the squared error. If you remember sum of squared error that we have talked in the decision tree, in order to just render that decision tree regression. If you remember regression tree, we plotted this sum of squared residual or sum of squared error. So same function will be used over here. So this linear regression is going to create us a function which will minimize this error, either absolute error or squared error. So if you have a absolute, you can see there is a absolute over here. If there is a squared term, you just get the square of it. So this yi is nothing but a actual value, and fxi is nothing but a predicted value. And whenever we just subtract actual from prediction and take the square of it, then that is sum of squared error, or it can be also called as mean squared error. And whenever we take the absolute value only, then that is absolute error. So the algorithm, the goal of linear regression is to find a function that will minimize this mean square error, because we have to minimum, because this is a error. And whenever we minimize error, that means our model is accurate. We will have minimum error, means our model will be better. So our main goal of linear regression is to minimize this error. Now in the next lecture we will continue just building on this concept and how linear regression work, and we will talk about just implementing some of the logic, and we are going to code in the upcoming coding session. See you in the next